And now we're going to finish up the solutions for the backup review for Master Quiz 13. So when you get to the back, you have the shape here, and you need to prove that it's a rectangle. To do that, you need to get the slope for all the sides, and then get the length. So something that'll kind of help you out is first get the slopes. So if you go from B to A, for part A here, you have to go up 1, 2, 3, 4, so that number's going to be on top. And then you had to go over 2, so it's going to be 4 over 2, and that's the slope. And if you want to get the length, you take both of those numbers and you square them. That does simplify to be just 2, by the way. But you got to use the original rise and run. So there's a slope, and you got to square them. Then you can get 4 plus 16, which is going to give you the square root of 20. And that's it. That's going to be the length for that one. Okay, and you move on to the next one, your rise and run for this guy. Let's see. You had to go over 1, 2, 3, 4, 5, 6, 7, 8. So you had to go over 8. 8 goes on bottom. And you had to go down 1, 2, 3, 4. So you had to go down 4. So the slope for this guy is going to be negative 4 over 8, which is the same thing as negative 1/2. And if you want to get the length, you're going to take both those numbers again and square them. So 8 squared and negative 4 squared. And if you square them both, you're going to get 64 and 16. And if you add those up, you're now looking at the square root of 80. Okay. So we got some slopes, some distances. ED here. If you get the same rise and run as the original one, you're going to have the same distance. And so, let's see, if you look at it, what's our rise? 1, 2, 3, 4. And the run is 1, 2. And so, yeah, the rise and run are the same. So slope's still the same, which is still 2. And that's going to make the distance the same. It's still going to be square root of 20, just like BA. We could go through the calculations again, but it's going to be the exact same. And then the slope for BE from here to here. Let's see, our rise is 1, 2, 3, 4, and the run is 1, 2, 3, 4, 5, 6, 7, 8. So you had to go down 4, right 8, and that's our slope, and that simplifies to be just negative 1/2, which is the same as AD, and that means our distance is going to be the same as well. So we got that. And now you have the slopes and distances. You can write a little sentence here at the end. So you can say that, like, since BA is the same as ED, as in those are the same distances, AD is the same as BE. The opposite sides are also parallel, so BA is parallel to ED, and and then AD is parallel to BE, and there's this part here that a lot of people keep missing. If you want something to be a rectangle, you have to mention that the slopes are opposite reciprocals, and so they meet at right angles. And BA is perpendicular to AD, and we have that on the other side as well. We have a AD perpendicular to ED. This shape is going to be a quadrilateral, so quadrilateral. BADE is a rectangle. I'm running a spacer. There you go. Nice long sentence saying about all the stuff that's true about it. And that brings us to the next one. See, you need to say what type of quadrilateral it is, and then refer to your work here to prove that it's set. This looks a lot like a parallelogram, but you have to figure it out if it is first. The slope for F to G, well, the rise from 5 to 3 is going to be negative 2, so we're looking at a slope of negative 2, over, and well, from negative 1 to 3 is 4, and so my slope is negative 1/2. And if you want to get the length, you take your original rise and run, and you square those numbers and add them up. And 4 squared is 16, and negative 2 squared is 4. And so again, we have the square root of 20, which seems to be a popular choice. So slope of negative 1/2, length of 20. The slope for GH here is going to be a little bit different. The rise from 3 to negative 4 is negative 7. Working on the slope here. The run from 3 to 6 is going to be 3. And that doesn't simplify much, so my slope is going to be 7/3. Let me get a little bit tighter. And if I want to get the distance, I'm going to take both those numbers and square them. So 3 squared plus negative 7 squared. Well, if you square 3, you get 9. If you take 7 and you square it, you get 49. And it's going to be positive. 9 plus 49 is going to be 58. So square root of 58. If JH or HJ comes out to be the same slope as FG, then we can say the distance is the same. So slope, well, the rise from negative 2 to negative 4 is negative 2. So I just go down 2. And then from 2 to 6 is a run of 4. And that's going to be the same as the original one. So it has a slope of negative 1/2. And the distance is going to be the same, square root of 20. And then FJ, right here, let's get the slope first. So slope from 5 to negative 2 is a rise of negative 7. You have to go down 7 to go that far. And then from negative 1 to 2 is a run of 3, which is the same as GH. And so the distance for this guy is going to be the same as that one up there. Okay, and it's looking like these slopes are not opposite reciprocal, so it's not a rectangle or a square. And the sides are not the same length, so it's not a rhombus, which leaves it as a parallelogram. So we're going to say parallelogram because, and we'll start writing down some of the things, FG is going to be the same as HJ, and they're parallel, so FG is parallel to HJ, and the other pair of sides are equal and parallel. So because GH is the same distance as it is from F to J, and that's a J, FJ, and GH is parallel to FJ. It's because they have the same slopes, by the way. They're parallel. And this whole thing's a parallelogram, and there you go.